Hello growers, I'm Dr. MJ Coco from CocoForCannabis.com. We publish articles, tutorials, and guides on the science and practice of growing cannabis. Today, I'm excited to bring you a grow light unboxing, par test, and review of the ViparSpectra P1500. We're going to have some fun with this one. It's a good little light, and I will put it through its paces to see what it can do. I'll run our standard par test, then a bonus par test to explore the laws of the universe, and finally, I'll run a dimming test. Stay tuned. Grow light par testing is part of the Grow Light Guide project. We're collaborating with Shane from MyGrow to conduct honest and impartial grow light tests and reviews. Check out our grow light articles, our grow light calculator, and all the grow light par test reports from Coco for Cannabis and MyGrow. Links are in the description. Today I'm testing the ViparSpectra P1500. ViparSpectra shipped it to me through Amazon, so it arrived in a standard Amazon box. Inside the Amazon box is just the next box with the fixture. And inside that box, first, we have a thick piece of cardboard for protection, then a thick piece of foam padding, and there's the fixture looking up at us. I'll grab the fixture, and below it, let's see, we have a hanging kit with cables, and we also got some ratchet pulleys. I'll put that aside, and let's inspect the lamp. This is a quantum board surface-mounted device. It has an aluminum ribbed heatsink and features these green accent colors, which might appeal to some growers. The driver is mounted on the top, and it has a convenient dimming knob, which I will demonstrate. The grid here is 15 centimeters, or about 6 inches, so the fixture is about 12 inches by 15 inches. The P1500 is part of the Pro Series from ViparSpectra, which is currently the top of their line. Let's check out the manual. The manual here covers all of the fixtures in the line and offers the basic descriptions that you might expect. We'll review the manufacturer's specs on their website in a second. First, let's get it hanging up. The Pro Series fixtures use SAN diodes, which have a waterproof coating, as you can see. For a long time, ViparSpectra has made lower efficiency Blurple lights, but the Pro Series is their entry into the quantum board market. These are geared to compete with the wave of relatively low-cost fixtures that beat traditional HID bulbs in efficiency. I'm curious how this fixture will stand up to the recent offerings from Mars, Spider Farmer, and others. It comes with everything you need to hang it up. The clips go into these holes here on each side of the fixture, and they provide 4 clips, but the cables are really too long, I think. I tried to use all of them, and it really limited the height that I could hang the fixture. So I ended up just using 1 cable and put 2 clips per side and then clip the ratchet pulley to the cable. This will mean that I need to make sure the fixture is hanging level, but that's not a problem. Alright, I plugged it into the power meter, and now we flip the switch, and we have light. Alright, let's check out the dimmer. Yeah, it is a convenient dimmer. I'll test that thoroughly in a bit. Let's take a look at the diodes. The P-Series lights use a couple of far red and 660 nanometer chips, along with the SAN diodes in 3500 and 6500K. LED diodes are most efficient when they are new and cold. I always try to test brand new fixtures to make accurate comparisons, but we always let the fixtures warm up before testing. While we're waiting, let's check out the product page for the P1500. Alright, here we are on the ViparSpectra website. On the product page for the P1500, we can see that the current price is $150. When we have discount codes available for ViparSpectra lights, we will list them in our calculator and test report page. We currently have a 15% off code, and I'll show you that in a bit. Always be sure to check the Coco for Cannabis Grow Light Guide when you're shopping for grow lights. Okay, I like to get a sense of how powerful the light is going to be before testing it. This allows me to know what size grow space it should be tested in. I will look for the data that we need to use in our grow light calculator. Reading through the description, we can see that they claim it draws 150 watts. Looking through the rest of this data for anything about PPF or efficiency, but there is none here. I will note that they recommend a 2.5 by 2.5 foot flowering coverage area. Okay, the lack of PPF data is a strike against any high efficiency fixture. I believe that manufacturers should list credible PPF or efficiency ratings if they are claiming that the fixture is high efficiency. When you cannot find PPF data or an efficiency rating, you might be able to get information that you need from a PAR map. ViparSpectra provides PAR maps here in one of the product images. And when I first visited this page, I found some issues with their PAR map data that had me concerned. I informed ViparSpectra about the issues, and to their credit, they quickly corrected them. I was pleased with their response, and I'm confident that these are reasonable PAR maps. They are not perfect, though. They are from a 3 by 3 foot area, which is larger than ideal for this fixture, and they were measured in a grow tent. However, we can certainly use them for a rough estimate of the power of the P1500, but it requires doing a little math. Let's review some grow light metrics, PPFD and PPF. I'm going to show you how to do this, because if a manufacturer does not provide PPF or efficiency data, this is one of the ways to get data that you can enter into our grow light calculator. I'm going to work with the 12-inch hanging height map, because it comes closest to our protocol for PPFD. However, I do expect this map will somewhat overestimate the fixture due to the low hanging height and the large test surface, but it's the best place to start. To understand the amount of light a fixture will produce, we need to know the photosynthetic photon flux, the PPF. PPF is a count of the photons that the fixture produces each second. It is measured in micromoles per second. And PAR maps generally do not list PPF. They list PPFD, photosynthetic photon flux density. PPFD measures the density of photons at a particular spot. It's measured in micromoles per square meter per second. The values in each cell of a PAR map here are PPFD measurements, and they describe the density of photons hitting each cell in this simulated grow space. So PPFD is a density measurement, but what we need is a quantity measurement. We can convert PPFD to PPF by multiplying the average PPFD by the area in square meters. Average PPFD times area in square meters equals usable PPF. Okay, so first we need to get the average PPFD. And since the map includes a value in each square, this is pretty easy. We're just going to add up the values from each square and divide by the number of squares. That gives us an average PPFD of 350.1. Now we need to multiply that by the test area in square meters. This is from a 3 foot by 3 foot test, which is about 90 centimeters by 90 centimeters, or about 0.81 square meters. So 350.1 micromoles per square meter times 0.81 square meters gives us an estimated usable PPF of 283.6 micromoles. Again, this is just a rough estimate, but it's a better estimate than using other types of data. Alright, let's scroll through the rest of the page. And down here, they provide some other data, but again, not exactly what we need. You can see that they're trying to describe the fixture based on HPS replacement values. And please just ignore this type of marketing when you see it. Manufacturers love to come up with these numbers. ViparSpectra is certainly not alone in doing this, but how they establish the equivalencies is a complete mystery. They claim the P1500 replaces a 400 watt HPS, but a 400 watt HPS produces about 530 micromoles of usable PPF. And our preliminary estimate based on their PAR test is that the P1500 is about half that. Rather than relying on HPS replacement claims, always try to get PPF data to understand the size of a light. And if you're wondering what to do with PPF data once you get it, that answer is simple. You take it to the Coco for Cannabis Grow Light Calculator. This is our tool to help growers analyze grow lights. Rather than trusting manufacturers about coverage or power, the calculator allows you to do your own accurate estimation. You can take manufacturer data about power draw, cost, and PPF and use it to estimate what the fixture will actually produce in your grow space. So let's enter the rough data that we got about the P1500 and see what the calculator says it can do. It draws 150 watts, it costs $150, and then we need PPF data. When you use the calculator, it's really important to select the correct type of PPF. Normally, data from manufacturers should be entered as calculated PPF. However, since we pulled our PPF data from a PAR map, it is usable PPF, and we got 283.6 micromoles. As soon as we enter that, the calculator provides us with estimates for photon efficiency, cost efficiency, coverage, and even harvest potential. With 283.6 micromoles of usable PPF, the calculator is estimating that the fixture will cover 4.4 square feet. ViparSpectra claims it covers a 2.5 by 2.5 foot area, but that would be over 6 square feet. According to the calculator, and according to our testing protocol, the P1500 should be tested in a 2 foot by 2 foot area, so that's what I'm going to do. We'll come back to the calculator and run the numbers again with the test data, but this confirms my assumption about coverage. Alright, the fixture is all warmed up and ready to test. I'm going to surround it with my mylar walls to create a 60 by 60 centimeter, or roughly 2 foot by 2 foot space. Once it's surrounded, I'm going to take a lot of care to make sure that it's perfectly centered and level, and that takes some time. But once it's centered and level, I start looking at the PPFD readings to determine the proper hanging height. I'm going to raise or lower the fixture until the maximum PPFD is up to, but not over, 1000 micromoles. Alright, I think I got it. The hanging height here is 37 centimeters, or 14.5 inches. I'll show you the PPFD reading here on my phone. Our maximum PPFD is now 991 micromoles. At this point, I move the sensor around the middle a little to ensure there are no higher readings, and there aren't. So I'm ready to start recording PPFD values and building our PAR map. To build a PAR map, we record the average PPFD value for each square in the grid. By taking a reading right in the center of the square, we get very close to the average value. Once we have a good PAR map, we can do a couple of things. First, we can see the distribution of photon density, which says a lot about the quality of the fixture and the results you will have from it. Second, we can use the average PPFD to calculate the total amount of photosynthetic photon flux. This is exactly what I tried to do with the map on the ViparSpectra website. Alright, I have recorded all my PPFD values, and here is the map. This is actually a really good 2x2 PAR map. On my maps, there are never values above 1000 micromoles, and the lowest reading here is 548 micromoles, which is perfectly fine for a corner. There is a good distribution and good photon density values. I think this confirms that the 2x2 area is correct for this fixture, but I think I'm going to go ahead and run the second test in a 2x3 area just to see what it can do in a larger space. Before we do that, let's run the numbers on the P1500 from this test. So first we need to take the average PPFD. Across this PAR map, the average is 716.6. And just like we did before, we can multiply that by the area in square meters. This test area is 0.36 square meters. That gives us a usable PPF of 258 micromoles. That's just a little lower than we estimated from their PAR map, but it's a good number. Finally, I measured a power draw during the test of 144 watts. Let's take that data and go back to the calculator. Alright, we're back on the calculator with some reliable data, so we can finally get a sense of what the P1500 can really do. I'll enter the data from the PAR test. I measured 144 watts, we know it costs $150, and the PPF data that we have is from a PAR test, so it's usable PPF. And I measured the usable PPF to be 258 micromoles. You can always enter data like that for a fixture, but you might notice here that I also have the P1500 loaded already among our preloaded fixtures. We load all our tested fixtures here, and you can easily browse and compare. Okay, the key stats on the P1500. I'll enter the price here. If you don't know the current prices, we provide links, and when we have discount codes, you'll find those here as well. Please use our links when you go shopping for grow lights. It helps to support our work. You know, this is a good result. The P1500 has a photon efficiency of 1.79 micromoles per watt. That is lower than the Mars and Spider Farmer fixtures that I've tested recently, but it's still really good. 1.79 is more efficient than any HPS or other gas discharge lights. The cost is 58 cents per micromole, which is great. This is certainly an affordable fixture. The price is lower than most similar fixtures. Really, only the TS series from Mars can match the efficiency and beat this price. The coverage listed here is exactly 4 square feet. I could tell that looking at the PAR map that was correct. We're about to see what it will do when we put it in 6 square feet, and we already know it's not going to be enough light. Finally, the harvest potential. The harvest numbers here are not a firm prediction for your grow, but they do help to understand the potential power of the light. We estimate that the P1500 can produce a harvest of 194 grams, almost 7 ounces. 194 grams from a fixture that draws only 144 watts is pretty good. With all our tested fixtures, you can also find a test report page. You can link to it right here in the calculator or through any of the drop-down menus. You will find this video at the top when you come to the page, followed by the test report data that we just reviewed. I'll enter the cost here and we can see the cost efficiency. And below this area, you'll find all of the specific PAR test data, and you can review the PAR map. Down here, you can enter your grow space and see how many P1500s you will need. In a 4x4 grow space, we would need 4 of these fixtures for a total cost of $600. And below that, you'll find my written review. But I'm not quite ready to wrap this report up yet. I want to run another PAR test, and I need to test out the dimmer. Let's go back to the testing rig. Alright, so I want to run the P1500 in a 3x2 area, and we can use this as an opportunity to review some grow light physics. You recall the data from our 2x2 test, and I'm going to add that the 2x2 test had a great distribution of light. There are some rules that we can use to make predictions now about what will happen when we change the coverage area. I'm going to go deeper into these rules in an upcoming video with the Mars SP3000. I tested 1 and 2 of them in several different configurations, and it's an interesting way to explore the laws of physics. We can explore some of those laws in action here too. We're going to do a 3x2 test, and when test area or grow space increases in size, we can predict several things. First, we're going to need to lower the hanging height in order to maintain the same target PPFD. The larger coverage area will result in a lower average PPFD across the PAR map. Our test area is increasing from 0.36 to 0.45 square meters, and this is going to lead to a higher usable PPF. Essentially, the photons have a larger target, so more of them are going to hit the target. We have no reason to anticipate any change to the power draw, and that means that we will get a higher efficiency. Now, a higher efficiency may sound great, but it comes at the expense of distribution. There will be lower values and a larger spread from the highest to the lowest PPFD readings. Okay, I got the walls moved out to 2x3, and we can already see the first prediction. I have not moved the fixture. I only adjusted 2 of the walls, and in a 2x2 space, we had a maximum PPFD of 991 micromoles in the center. Now with the walls moved back, it's only 897. This is because we increased the distance from the lamp to the walls, and fewer photons are getting reflected back to the center. I have to lower the fixture a full inch, down to 34.5 centimeters, or about 13.5 inches, and that brings us back to the 996 micromoles as our max PPFD. Alright, I'm going to run this test carefully and take all the PPFD readings from the squares. Certainly these are lower numbers than I recorded in the first test. And that makes sense. Alright, let's check out the PAR map that the P1500 produces in a 2x3 test. You know, just as we predicted, this is too much space and it results in a much worse PAR map. We added the column of squares on each end, and you can see that in all of the area that we added, the light is less than ideal. We always want to have at least 500 micromoles in each square. And if you're curious about why this is, please read my article, How Much Light Do You Need for Indoor Cannabis? The link is on screen and in the description. Just looking at the center 2x2 foot area, you can see that our PPFD numbers have gone down there as well. I'll show you the 2x2 map to compare. And then back to the 2x3 map. With more area, the photons are simply more spread out. With a 2x2 area, the photons are concentrated in that 2x2 area. And when we add the space, the light spreads into those regions, and that lowers the PPFD everywhere. Okay, let's run the numbers on the 2x3 test. I predicted that the average PPFD would go down in this test, and it certainly did. We had a great average in the first test of 716.6. In this 2x3 area, the average has fallen to 507.33. It's a larger test area though, so we do have the increase in usable PPF that I predicted. It is 274 micromoles now, up from 258. Since the usable PPF went up and the power draw stayed the same, we realized an increase in efficiency. In 6 square feet, the fixture gets 1.9 micromoles of usable PPF per watt. However, since there's more area than light, the distribution is bad. Lots of territory here in the map is below 500 micromoles, and there is a large difference between the highest and the lowest regions of the coverage area. The P1500 is a great light in a 2x2, but I don't recommend it for more area than that. Alright, there's one more test that I want to run. Let's check out the dimmer and see how accurate the dial is. Right now the fixture is at maximum power, of course, and the center reading is still 997 micromoles. And we're still pulling 144 watts from the wall. Alright, I'm going to dim the knob to the 75% position. And our center PPFD went down to 832 micromoles, which is actually 83.5%. And the power is 117 watts, which is 81.3%. So it's a little strong. Let's set it down to 50% on the dial. And now we have a center PPFD of 616 micromoles, which is 61.8%. And the power's gone down to 83.8 watts, which is 58.2%. I'll set the dimmer down to 25% power, and our center PPFD has gone down to 347, or 34.8%, and power at this point is 44.8 watts, about 31%. Finally, I'll turn the dimmer all the way down, and that brings the PPFD down to 95 micromoles, or 9.5%, and the power now is 8.75%, drawing only 12.6 watts. Okay, so be advised, the dimmer runs a little bit on the strong side, but it's pretty consistent throughout, and there's a close relationship between the power draw percentage and the PPFD percentage. Alright, back on the review page here, you can find my complete written review of the P1500, along with the maps I show in the video. I think it's a competitive fixture. I'm really happy to see ViparSpectra enter the quality LED market and produce a fixture that we rate as elite efficiency. The LED market has come a long way in a short time, and it's great to see mass-produced like ViparSpectra making high quality and high efficiency fixtures. To be honest, I was not expecting to like the fixture. I think years of overhyped Blurple lights have soured many growers to brands like ViparSpectra. But companies like Mars Hydro and ViparSpectra are now producing much better fixtures. And I really appreciate that ViparSpectra responded to my critiques of their webpage and marketing tactics. The more time I spent with the P1500, the more I liked it. It gets an elite efficiency rating and has a good distribution if you put it in the right coverage area. It's a pretty small fixture, but might be really convenient for small grows. The small footprint and the dimming feature would make it a great light for young sprouts and seedlings. You can ramp up the dimmer during the seedling stage and then add additional fixtures as the plants grow larger. The P1500 will be an efficient seedling light and fully capable of covering a 2x2 area in the flowering room or tent. Two of these fixtures would work very well in a 2x4 tent and provide great flexibility to home growers. One complaint I have is that the driver is not removable from the P1500, but I will admit that heat did not seem to be an issue. The highest temperature reading I got from the heat gun was only 124 degrees Fahrenheit. The ribbed aluminum heatsink does a really good job managing the heat. In comparing it to competitive fixtures, I think the Mars TS1000 is the closest analog. The TS1000 and the P1500 both put out the same amount of light and get about the same efficiency. The dimmer on the P1500 is certainly better, but the driver is removable from the TS1000, and it comes in at a slightly better price. If you're looking for a small light, they would both be great options, and it's wonderful that great options like these are now available for most growers. I have a few other thoughts about the P1500, so be sure to read my review. And below my review, you'll find a set of our shopping links. Coco for Cannabis grow light testing is unsponsored and impartial. We do not get paid for testing lights, but we do earn commissions when you make purchases through our links. Our goal is to provide reliable, science-based testing and reviews for home growers. You can support our work simply by following our links when you purchase a grow light. And of course, when we have discount codes available, we will list them here. I'd like to thank John from ViparSpectra for sending me the light to test. Please like the video and subscribe to my channel. You should also be sure to subscribe to the MyGrow YouTube channel. And follow me on Instagram at Dr. MJ Coco. I hope you come to visit us at cocoforcannabis.com. We are dedicated to the science and practice of growing cannabis. Check out our table of contents and all of our features. You can chat with our community, browse the grow light test reports, and try your hand at the grow light calculator. Join us for our next grow challenge and you might win this P1500 or another fixture that I test. And check out my recent grow light reviews for the new Mars Hydro SP3000 and the Spider Farmer SF2000. Look for my new video coming out soon on grow light coverage areas with the SP3000. I pick up on some of the issues we started talking about in this video. And there are more grow light par tests coming very soon. I'm Dr. MJ Coco, sending grower love to everyone.